Group, a new space startup. My real congratulations to you for taking up this task, and I welcome everyone, the participants, the listeners on this today's program. As Surendran told, so their primary objective is is to have a startup company in the area of space and astronomy. And what I heard, understand from them is one of their main area is the ground segment. That is to have a full-fledged end-to-end solutions for the ground station, including the training of personnel for the ground station, and including the hardware and everything. So I think my talk will be in line with their view. One of their main objective to provide a complete solution for the ground segment, mainly one of their, including the payload development. So that's the reason I thought I can take up this particular topic today, like a space communication. The main idea of today's talk is just to tell you how simple and inexpensive it is to engage in the space communication in a very, very small way, like learning like as a very big science in a small way. So that's all about my talk today. So I'll be taking through you my presentation, and always to begin with, that's my salutation to our scientist, Sir Jagdish Chandra Bose, who has done a great contribution to the wireless communication, radio wireless communication, and as well as to Guguli Mamakoni. With this, so today's aim, the aim of this presentation is to acquaint and let know a common person how simple, inexpensive, and practical is to track satellites and other space objects in real time, and to predict satellite path timings, as well as to receive and decode real-time telemetry and payload signals from certain class of orbiting satellites. And of course, we are all going to do this from your own home. Okay, that's all we can pursue from our home. So I'll just tell you, so this is what the aim of the presentation. And when we say that receiving signals and decoding and tracking of satellites, definitely one might think that we need a yes.
The voice is cracking. It's not clear.
I think that's the network. Is it okay now? Hello.
Sir, it is fine
okay.
here. Devankrati, kindly check your internet too. It is fine here, sir. You can, yeah.
Okay.
Okay,
so,
sorry.
And definitely not this way, as you have been seeing. Okay, you don't need really a big setup, because generally when we say satellite communication, the first thing to come to our mind is a huge antenna, dish antennas, and huge panels of equipment, and a big, huge control room, and having too many people there sitting. And so definitely not this way. So this is going to be this way. So before I go into that, so we all know that. So now today we are going to deal with the space communication. So we know that there are two types of communications mainly. One is electronic and non-electronic. And of course, we are going to concentrate on electronic, and that we have two different systems. One is wired and one is wireless. And again, under wireless, there are two areas. One is the terrestrial transmissions, communication, and another one is space. So obviously, we are going to concentrate on the space communication. So this is how it goes. Like, just a little bit of a history. So when we are talking about satellites and space communication, certainly we need to know the space age. The world's first artificial satellite, we all know, that was launched by Russia, the erstwhile Russia. And the first satellite, the man-made artificial satellite to go into space, was Sputnik 1 on October 4th, 1957. And since then, there are more than 2,000, 2,500 satellites have been made and launched into the orbit. And it's much more. It is definitely much more than that. Okay, so let us see why this satellites are so important. See, among them, there is a class of satellite called Oscars. It is nothing but amateur radio. It's an orbiting satellite carrying amateur radio. So, hope some of you might be aware of what is a ham radio or amateur radio. Certainly, maybe in another different session we can talk about it. So, there is a class of satellites made by this hobbyist amateur radio operators, and there are about more than 120 satellites have gone into space made by this space hobbyists, amateur radio operators. So now, just to put it in a simple, we all know that a satellite is a heavenly body which goes around a planet in a particular orbit or a path. And we know that there are two types of satellites. One is a natural, for example, the moon in our solar system, and artificial satellite. And those are the ones built and launched into space by humans. And so let's see why the satellites are so important. Because today's satellite-based applications are numerous. Okay, it is really numerous. Particularly, we use it for communication, TV broadcasting, weather forecasting, remote sensing, cartography, and for military applications, and natural resource drought management, relief and rescue, telemedicine, and of course everything. Almost for every application now today, satellites are used for those applications and for the purposes. So based on the application, the satellites are classified into groups like communication and remote sensing, weather, planetary exploration, reconnaissance, scientific, and of course there is a group, as I told you, there is another category group of satellites called amateur radio satellites. Those are all the ones made and launched by radio amateurs around the world. And I know there's a difference between the advantages of a satellite communication over a terrestrial communication. So now, before 1957, definitely everything was terrestrial mode. Okay, but after 1957, when the first satellite went into space, and the satellites have been started, using for mostly for the communication purposes. The main advantages of a satellite communications are, like, it can cover a very wide area, almost literally half of the globe, and it's very reliable, predictable, consistent, and of course we have a very quality radio communication compared to the terrestrial communication mode. And we get a very high bandwidth and different modes. We can try out with different modes of communication, and these are all one of the major satellite communication. That's the reason every nation, every tiny nation also wants to have their own space program, having their own satellites for various purposes. Now, and definitely we have some disadvantages of satellite communications, like launching satellites into orbit is very, very expensive. And of course, the bandwidth, because the bandwidth has been very widely used, and so we have to mitigate, or we have to go on for very higher bandwidths and higher bands of frequencies. And there will be a slight propagation delay due to the altitude of the satellites. So these are all the disadvantages of a satellite. Otherwise, we have satellite communication, but whereas there are many, many advantages of satellite communication. So we all know that what is the present day we are living in. So what sort of a luxury we are enjoying? It's all because of the satellite communication. So literally for every application we use the satellites. So that's the reason we could have such a very comfort life the present day when you compare to about 30, 40 years ago. And so these are all the basic things, because there could be a mixed audio. We also, so if you want to launch a satellite, we need to launch we call it a rocket.
Subramani sir. Subramani sir. Sir, your voice is breaking. I guess, sir.
Then is it okay now?
Yes. Now it's clear.
Okay. So we just, if you want to know how a satellite stays in orbit, we know that only two laws. That is, one is the Newton's law, another one is the Keplerian's law. And the Newton's law gives you about the conceptual description, and whereas the Kepler's law gives you the mathematical description. So based on this, the orbit, and the term orbit is an orbit, is a closed elliptic path from which a secondary body is the primary body. Here the equator. So when we in around as a orbit,
Sir, voice is
go in
cracking
any
too
direction,
much.
but how is it now? I don't know whether it is over modulation or how is it?
So now your voice is fine, Paka. But when you're going to presentation, it is taking a break.
Or is it only when I change my slides? Is it that around that time?
Yeah, I guess.
I don't know why then.
Your
Okay.
screen share stopped. Your screen share and your video mode is stopped.
Is it okay now?
Just a minute, sir. I will give the access. Now
I
you
think
can
that
start.
is due to the connectivity, Surendran.
Yeah, I guess. So maybe, sir, you can. You don't need to switch your camera on. You can switch your presentation mode and then go ahead because camera mode will eat internet.
Yeah, that's okay.
Yeah. Maybe you can just move with the audio mode.
Here, my webcam is closed only.
Sir, now I have given the presentation access. You have to share your screen, sir.
But it's, are you able to see now?
Not yet, sir. Sir, just come to the class meet and share your screen once again.
Is it okay?
Yeah, it is sharing.
How's the
Yes.
video, audio now?
Yeah, audio is fine, sir.
Okay. Sorry on that. Very sorry because the
No problem.
poor connectivity. So this is about the orbit. But generally what we do, we choose a certain type of orbits which are very useful for a certain class of applications. So for example, though we can launch the satellites into any orbit, but the real case is that we need to go at certain altitude in certain direction to accomplish certain applications. So for example, we have a low Earth orbit that varies between about 2090 and 1,600 kilometers. And see, this is over the surface of the Earth. And this kind of orbits, we call it as a low Earth orbit. And when the satellite is put at around about 10,000 to 16,000 kilometers, so we call this as a medium Earth orbit. And there is another very important orbit, very most popular and widely used, is the geosynchronous or a geostationary orbit, which is about 36,000 kilometers from the surface of the Earth. And here, when we say the altitude, we can just make the orbit to incline to any angle, okay, depending upon the requirement with reference to the equator. So, for example, generally the low Earth orbit satellites meant for the weather forecasting and for the Earth observation, we generally make the satellites to go over the poles. So, North and South Pole, and we know beneath the orbit, the Earth keeps rotating on its axis, taking about 24 hours. And that is the constant. And the satellites again can be made to go over the equator, even in an inclined orbit. And of course, we generally put the satellites at around 36,000 kilometers over the equator and see that it just goes over the equator at a distance of about 36,000 kilometers, taking about 24 hours to make one rotation. And whereas the Earth also takes about 24 hours to make one rotation on its axis. So here, the satellite appears to be stationary, And in this case, since it is appears to be stationary, though it is moving at a high velocity, but these kind of applications, the orbits, are meant for communication purposes, because always the satellite appears to be stationary over a given place on the Earth. So this is about a small description about the different orbits. Now, so today we are going to concentrate or more on the low Earth orbit, and mainly the polar ones. Here, this satellite doesn't stay at one particular place like a geostationary orbit. And for two reasons. One is this is made to go over the poles, unlike over the equator. And second thing is this is a much lower altitude, say around from 400 kilometers to about 1200 kilometers generally, practically. And these satellites, since they go around the Earth over the poles, and the Earth also keeps rotating on its own axis, so there will be always a difference of, like, the difference of the motion between the observer on a given place and the satellite. So the satellite comes from
Excuse me,
different
sir.
directions. Yes.
So, are you presenting the slides? Because I'm not able to see any slides. It's completely black.
Surendra?
Devankrati, it is fine. It is already screen is shared. Maybe check your internet connection. It is pakka here.
Okay.
Yeah. Otherwise, maybe you can. If you have any problem, maybe you can go to the YouTube. I will share the YouTube link. If anybody having a network issue, you can watch it from YouTube.
Okay. Thank you, sir.
It is
Okay.
pakka here. Sorry. Yeah.
So these satellites are very interesting ones because they keep moving over different places at different times. And almost like a sunrise and a sunset, it appears in one direction, sets in another direction. And again, unlike sunrise and sunset and visibility, availability of the sun, 1 second. 11:45 call பண்றீங்களா? Okay. So, sorry on that. There was urgent call. So this needs to be, these kind of satellites are very interesting to track. Okay, it appears in one direction, sets in another direction, appears for a very short time, and maximum these kind of satellites will be visible only for about 14 to 16 minutes. Okay, and so this kind of satellites, hello, 12 o'clock on பண்றீங்க, please. Okay. Sorry, that was a very urgent call. So that's about the real-time tracking. So let's see why we need to track the satellites. So the satellites, because particularly when we say tracking, the satellite, it really says that the satellite is moving. See, when something is moving, we need to track. Okay, when it makes differential positions between the observer and the satellite. So when it keeps moving, we need to track it. For example, the geostationary satellite doesn't move, though it is traveling at a very high velocity, because the velocity, the rotational velocity of the Earth and the rotational velocity of the satellite, both are synced, both are synchronized, and so it both takes 24 hours, and the satellite appears to be stationary. So there, the satellite, the tracking is not required, only during the initial periods when the satellite, till the satellite is parked. But whereas the polar satellites and other low Earth orbit satellites, so we need to track it because they make in a different directions and they move in a different altitude, and also in different directions. So these kind of satellites needs to be tracked. Like, we know sun rises in the east and sets in the west, and we know the sun makes a different angle from the point of the observer on the Earth. So like that, the satellite also keeps rising and setting at a particular directions, and so these satellites needs to be tracked. And so let's see why the satellites and how and what, so who can do this, and when and where to look at the satellite for the tracking. So see, it's a fact that all the space objects would follow a definite path unless otherwise disturbed by any external force. Okay, so this is a fact, and since these satellites are also are traveling in space, it doesn't mean that there is no any external force disturbing its motion, but definitely there are also some disturbing forces in the space, like gravitational pull of the Earth and Moon, and of course other planets when it goes out of the influence of the Earth. And we have solar pressure, which can disturb the motion of the satellite, and aerodynamic drag that depends upon the structure, the size and structure of the satellite. And of course, we have an intentional maneuvering of the satellites by ground control. So all these factors makes the satellite to disturb, so that certainly the altitude, the velocity, and everything can be disturbed. And when this is disturbed, it cannot follow the rule that we say that a body will continue to be in the same state. For in this case, a state of motion. So we'll see why the satellite needs to be tracked, particularly those satellites and space objects which are not stationary, as I told you. But for kindly make sure that every object in the space is moving. Okay, it cannot be stationary. But when we say it is stationary with reference to a point on the Earth, if both the rotational velocity of the satellite and the Earth, if it is synchronized, it appears to be stationary, but nevertheless it keeps moving. Okay, whereas the satellites, for in this case, you can see a satellite is put over the poles, and the satellite is going around the Earth from North Pole to South Pole, and then it keeps going around. And the Earth beneath the orbit is also rotating. So the satellite, the same satellite which came over one particular plane, orbital plane, over particular regions on the Earth, will not come again on the same place the next orbit. Okay, and after certain number of orbits, again it's going to come over the same place. So typically these kind of satellites, which are launched at an altitude of about 400 to 1200 kilometers, will take about 90 to 110 minutes. Okay, anywhere between 90 to 110 minutes to make one orbit. And you can just see when it takes about 90 to 110 minutes, that means it will just vary between these two timing depending upon the altitude, between 400 to 1200 kilometers. So the availability of the satellite over a given point on the Earth, it's going to be for a very short time, and typically it will be about 14 to 16 minutes maximum. Okay, in this 14 to 16 minutes, one has to track the satellites, and you have to get the information like the payload data, whatever it takes, whether it is a camera, whether it is a radar, or whatever the sensors, the payload. So you have to download all the data within this time, and also you have to send the commands to the satellites within this time. So it's very interesting. And when the satellite goes out of your range, you should know where the satellite is. Okay, so that is called the tracking. So we need to know the real-time position of a satellite after it leaves your place. Maybe after a few hours, if you want to know where the satellite is. So, and again, the other part is you should know when the satellite is going to come over our region, the visibility area. So it's very interesting. And so this is called the tracking, and why we do is. So particularly already I told you, and to know the current location in its orbit and follow the ground track. If you want to know where the location of the satellite in its orbit, whether it is in the North Pole or South Pole or midway, if you want to know during any particular orbit, we need to track the satellite. And so we can determine its position, velocity at every instant. And so definitely this is done to have the payload, like a data collection, and also to, if you want to upload any data in the sense, telecommands. So we have to do all this during tracking. So generally we do the satellites, the tracking for health analysis, because every second the health of the satellite is monitored through the chain of ground stations. And of course, we have a system and payload control. We have to control that. For example, switching on and switching off the camera or the radar or whatever. And then the payload data collection. So we'll be having hundreds and thousands of data collection ground stations where data has to be downloaded. So for all this, we need to track the satellite. And of course, one of the most important aspect, the present scenario is collision avoidance, because there are too many space junks, dead satellites going around in the low Earth orbit particularly. And certainly we have to take care of our satellite. And you would have noticed in the current news yesterday and day before, two satellites were coming in the close contact. So this kind of collisions are likely to happen, and so certainly we have to avoid this by maneuvering the satellite. So one of the satellite has to be either lowered or increased in the altitude so that it avoids collision in the space. So for that, one need to know where the satellite is. So for example, when we make a satellite, when design a satellite operator launches a satellite, from the moment it goes into the space till it dies in the space, and even after that, so it has to be monitored, its location and its velocity, position, everything. So that's very interesting. So if you want to put it like, what is a satellite tracking? It is an activity in which the position or a flight progress of an orbit is monitored. Interesting one. So very big interesting science, and what we learn and we teach, particularly we learn in a very very simple way, like a fun. We do this, and of course, what the big space agencies are doing, we can also do it in a very small way from our home. So now there are two real aspects of this tracking. One is the real-time position and tracking. The second is past predictions. So what is the real-time position? Real-time position is, it shows the satellite's current location and heading. So real-time position means we have to tell exactly where the satellite is in the orbit and in which direction it is heading, whether it is coming from North Pole towards the South Pole or from south to north, whether it is ascending or descending. So this one we have to say, and again where the satellite is in its orbit. This is called the real-time position. Second is past prediction. So we have to know that when the same satellite or a particular satellite is going to come over a given place of our interest or over a particular ground station. So this is called past predictions. Now, to know this, as I told you now, this is a very big technology, very big science, but we are going to learn as a fun. And all that one needs is a simple understanding. We need to have some planning and perseverance, and of course patience for everything. So these are all the basic requirements if somebody wants to learn about the real-time tracking of satellites and space objects. So let us see what are the technical requirements. So technical requirements is, one should have a PC and a computer program, and of course the what is required is the date and time and location details. The location details mean the observer's location detail from where you are going to observe, and a set of orbital parameters. So we will just see one by one and see how this can be accomplished. So the requirement one, it's a computer program. So this is nothing but a satellite tracking software. It's so called, and it does a position. It computes the satellite position and velocities using mathematical model of the orbit by reading the Keplerian elements. I'll just get back to you, come to you about the Keplerian elements. So the computer program, in a simple way, it just computes the satellite position and velocities, okay, using a mathematical model of the orbit. And it predicts the position of the satellite. It just tells you where the satellite is, and it provides the output either in a graphical or a tabular orbital prediction suite. Okay, it can just give you a graphical way also where the satellite is. So if you just put it, sorry, there's a power failure. Surendran?
Sir?
Surendran? Okay,
Yes,
there's a
sir.
power failure. I hope nothing should go wrong. Okay.
Okay.
Okay, my backup power is on. So
Okay, fine, sir.
in simple, it tells, the computer programs tells when and where to look for the satellite. And so what it needs a input, certain input. This tracking software needs certain inputs like current date and time and observer location on the Earth surface. That means our coordinates. So the computer program should know from which location we are going to observe. And of course, the third input is the Keplerian elements. Okay, so these are all the three things, inputs required for this computer program, which is the requirement number one. And if some of you can take a screenshot or take a snap, you can download some of the softwares. Most of them are free softwares. Okay, So I always suggest the Orbitron, which is a very simple and straightforward. And I always recommend that this Orbitron, the satellite tracking software for the beginners. It's a very simple one. And there are a few others, and so each one have its own features, advantages. So these are all the softwares, some of the softwares available for tracking satellites in real time. And requirement too, it's very simple, date and time. Of course, most of the time we will have the date and accurate time set in our PC, in our computers. But here, the time is very important. You have to have pretty accurate time set in your computers. So you can take your cell phone time, which is pretty close, which is pretty accurate also. So you can always take the cell phone time, and you can just put it in your computer so that it always have the accurate time. And of course, the date. And the third requirement for the program is, the observer's location detail. So this is nothing but latitude and longitude with altitude. So we generally get this from help of maps, GPS receivers, and we can get our observer's location from Google Earth, and of course from ISRO's Bhuvan also. So these are all the websites where you can get, and there is a fantastic website called www.aprs.fi, where you can just put the cursor. It will give you the coordinates of your place, and this you can feed it to the software. And fourth one is the orbital elements, or we call it as a Keplerian element. So this is a set of orbital parameters, also known as Keplerian elements. See, if you want to know the size and shape of the ellipse of the orbit, and the orientation and the location of the satellite, so with the help of a set of 7 numbers, you can define the orbit. Okay, so having the 7 parameters, it's called the orbital parameters. So one can really define the size and shape of the orbit. So what all those 7 is? One is epoch time, inclination, and of course there are certain things we don't want to go into this out of the scope of this presentation. And these are all the things. If you have this 6 to 7 parameters, we can define the shape and size of the orbit of the Earth-bound satellites. So orbital parameters, the fourth requirement to do the real-time tracking of satellites, is not that simple, because all the first 3, it's so simple. Having a computer, downloading a software, and having your coordinates, it's also easy. But the fourth requirement of orbital parameters is very difficult, and we cannot, any individual cannot really do that and get it unless we get it from the major source like NASA or from ISRO, because they have their own ways of deriving those orbital parameters. But of course, we also have a way out for this. And just to tell you what is the orbital parameters, how they are obtained, and these are generated by multiple observation using a network of ground stations, conventional radars, phased array radars, and so many other systems. It's a very complex, and it is a multi-million job. Okay, so it's not that easy for any individual to think and do it. But certainly there is an agency which can help us with this orbital parameters. So we have a agency, okay, called NORAD, North American Aerospace Defense Command. They are the ones responsible for the detection, identification, tracking of almost all the man-made space objects. They track every day about 500,000 space objects are being ranged and tracked every day. Just imagine. So they keep tracking everything 24/7, and they tag the numbers. Most of them are quite big, and anything above the size of a soft ball are numbered and tagged. And so these are all the orbital parameters for these objects are available to us by NORAD. So we can go to their website and we can download, and this is the one of the input required for the software, which is very important. Okay, without this, the tracking softwares cannot predict or track the satellites and give you the exact details. And this is one of the must important the must parameter for the satellite tracking software. And yeah, you can download, you can get these parameters from www. It is at the bottom, celestack.com. So you can just visit the website and you can download the orbital parameters, and all the 7 parameters along with few other parameters are put into a format called two-line elements, and this is called the NORAD two-line elements. So you can see all the 7 orbital parameters along with few other required information are put in this 2 lines. They are stuffed into these 2 lines, and this is how, and this is the format most of the softwares, satellite real-time satellite tracking softwares can understand. So this is called the 2-line element, or in short we call TLE. And so once you give the inputs to the software, this is how the outputs will be, like a graphical mode. This is called the 3D world projection. So where you can see the world and you can see the satellites. Here there is one satellite. It's called AO51. There is another satellite in the image, HAMSAT by India. And this white rings, you can see this is the footprint. That means these satellites from altitude of about 400 kilometers. So 400 to 500 kilometers, it can see only this much area of the Earth from about a range of about 400 to 500 kilometers. So this is how one of the output you can see, and there will be output in this way. It's called the map projection, where the world is being projected into a flat area, and you can see again the International Space Station on a very earlier date, 2011. So it's a screenshot on that particular time taken at around 7 o'clock in the evening, 7:10. So ISS was going, this is the orbit, and you can see the world, and this is the sun, and this is the moon here. So this is how one of the output of the software will be like. From this is particularly from a software called Orbitron. And this is again another projection from a different software, and you can see this is the home, my home here in Bangalore. And on that particular day, the International Space Station was making an approach over my place, over my location in this way. So the A here is mentioned as acquisition of signal. L means it's a loss of signal. This is the rise of the satellite, and this is the set of the satellite. From here, if you will, the satellite made a path over this place. So it was just going over the Arabian Sea. Okay, and it was visible in Bangalore from this location and up to this point. So you can make radio contacts with them. So this is again one of the other projection. And there is another projection also from one of the software called Orbitron. Again, this is projection. So this is the point where the observer will be located. And at this point in time, you can see the moon was here. And again, the time was 1905, means it is 7 o'clock, 5 minutes in the evening on 15th March 2011. It's quite old, I haven't updated. Yes.
Sir, I think you are using your mouse pad, I guess. Your voice is getting low when you are using the mouse. I mean, mouse pad or something else.
Okay, now is it okay?
Yeah, it is fine.
I don't know why all this happens. Okay, so now, of course, apart from the using a software, there is another way also. It's an alternate solution. It's a very simple, but it is an internet connection. So if you have an internet connection, there are quite a few websites where you can just get the real-time position of the satellite and also the past predictions. So like, if you go to the spaceflight.nasa or N2IO or Evans-Above, ISS Fans Club, I think that has been closed now. So you can just get immediate, without running the software, you can get the data from this particular sites also. So it's a very simple and straightforward, but the real-time satellite position will are made available at various internet sites. But you're not going to learn much there. But I always suggest, if you can have your software downloaded and if you can learn and get used to that, I think you're going to learn many things from it. So that is the one. And now, after having known little about, so why a satellite has been put into different orbit in a different direction, and the applications I've just told you, because in the shortest time, within one and quarter hour, really have to tell you all this. And the applications also you got to know. Mostly these low Earth orbit satellites are meant for Earth observation, okay, for reconnaissance and all these purposes. And definitely we cannot use it for communication purposes, but the group of people I told you, amateurs, radio amateurs, we mostly use these satellites for communication purposes, though it is available only for a short time. So that is about it. And now the second part is, having learned something about the real-time tracking and the past predictions. Now, all that what we can do is, having this knowledge, now we can try to receive signals from the satellites. Okay, this is also very quite interesting. So receiving a signal, see, because we have been listening signals from terrestrial communication, we keep receiving the signals from FM stations, FM radio stations, from medium wave radio stations, short wave radio stations, and all that. But how about receiving a signal from a satellite? This is most challenging and thrilling moments, because receiving a signal from a satellite, it's a really what do you call? It's very thrilling and very interesting. And of course, there is so much that we can learn, and mainly in the area of telecommunication. So one of the areas I already mentioned of Chigru's initiative is to provide the ground segment support. Okay, a complete end-to-end solutions for the tracking and receiving of satellite signals, and for decoding, and of course the hardware required to receive and upload and transmit also. So in this way, I think this particular topic, if you can learn how to track the satellites and how to receive the signals, it's very interesting. So now what we are going to do is learning wireless communication technology as a hobbyist. Okay, as a hobby, we are going to learn this. So now we know there are certain operations that are used to be carried out or required to be carried out by a space agency when they are launching a satellite into the space, like post-launch operations. See, whenever they launch a satellite, certain operations are must. So whether it is ISRO or NASA or JAXA or any other space agency, or even for that sake, even a small satellite operators, see, there are the certain post operations, the launch operations activities has to be done, like tracking. One should know about the position of the satellite. And second thing is, they should know determine the location, velocity, and the attitude of the satellite. See, one is altitude and this is the attitude. And second thing is the telemetry and telecommand. So they have to receive the telemetry signals from the space, from their satellites, and also they should be able to send the telecommands. So whatever the commands they have to send, so they should be doing it. And then system monitoring. So all the engineering systems of the satellites has to be monitored and controlled. And this is for the health analysis, because every satellite, whether it is a small or a big, these satellites has to be monitored every time. We always treat the satellites like a patient in the ICU. Every parameter of the satellite has to be monitored, and their health issues, and of course the housekeeping of the satellite, because we have to know the attitude of the satellite, and we have to keep the satellites in the control. So all this, like housekeeping, rate ranging, past predictions at ground track, payload operations, whether the camera, radar, or any other instrument on the satellite, that has to be switched on and switched off, and the data has to be collected from the ground stations, and orbital corrections and maneuvering. So all this are a mandatory, a compulsion things which a space agency has to keep doing as a post-launch operations. Now, as a space agency, so how about as an individual? Whether we'll be able to do some of the activities, if not all? Certainly, yes. We can also do as individuals. Okay, we need not to belong to any space agency, or we don't need to have any huge antenna and all this. But some of them, not everything, but we can also do it. So in turn, what we are going to learn many things about the space and space science. So becoming a space scientist not necessarily has to be like, one has to join ISRO or NASA or any other space agency and become a space scientist. So one can always make themselves as a space scientist. See, provided if you learn all that what they are going to learn or what they have learned, so there is not going to be any difference. But you are going to be a space scientist on your own. That's the only difference. But what they are going to learn, what they have learned, what they are going to speak, you are also going to do the same thing. So this we are going to do as a hobbyist. So now the post launch operations as an individual. So how one as an individual can get on to certain activities what the space agencies are doing. For example, as an individual, as a hobbyist or anyone, we can also track the satellites. Okay, using the software, we can also track. So we can exactly tell where the International Space Station is there and this point in time. And we can also do this determination of location of the satellite and the velocity, its altitude, and of course uh, telemetry we can do. So we can also receive the telemetry signals from certain class of satellites, not from all the satellites, but we can get this telemetry from some of the satellites, particularly the amateur radio satellites meant for amateur radio services. So from the CubeSats, nanosats made by the university students, so we can get the telemetry from these satellites. And system monitoring. So we can also do the system monitoring from this kind of satellites, health analysis, and the past predictions on ground track, payload operations. So we can also, as individuals, we can also operate some of the payloads, get through the payloads, provided if it is amateur radio satellites, and if you are an amateur radio operator with a valid call sign. But so point here is that we can also read, we can also understand, we can also get use, or maybe we can also make ourselves as a space engineer or a space scientist, but doing all this sitting in your home. Okay, and some of the, see, for example, for some of the satellites, we can also do the telecommand, provided if you are authorized by any amateur radio satellite operators or builders. Okay, so in that way, we can also do that. So most of the things what a space agency or a set of a space scientists or engineers doing in a space agency, we can also do that as a individuals. This is what we are going to learn today. And now, see, what is required again? Definitely, we don't need this kind of a huge antennas at our backyards, or a huge panels, equipments, and also this kind of a number of people and a big control room. But we can do it in this much simpler way like this. So you won't believe this gentleman stopped somewhere in between, and he's just trying to get through a satellite. That means he's trying to communicate through a satellite and maybe to talking to one of his amateur radio friend. Definitely he's a radio ham. So the huge antenna has been substituted by a simple handheld antenna, and a huge set of equipments, cubicles of equipment is been substituted by a handheld equipment called transceiver, and a microphone is using to just speak into the microphone and pushing the signal through a satellite. Is aiming that towards the satellite, the direction of the satellite. And a set of people, maybe about 50 or 100 of people, persons of people, is being substituted by a single individual. So this is how satellite communication can be pursued. So though it looks simple, but the science and the technology, everything remains the same. The theory, everything. So this is how we do, the radio amateurs, we do space communication in this way, but this is a much simpler way. So what I'm trying to stress or tell you is satellite, the space communication using satellites can be accomplished even in this much simpler way, in a very inexpensive way. So he knows about the tracking, he knows which way the satellite is going to go in the space, and he's using a simple handled antenna and a transceiver, and he's aiming that towards the satellite direction and moving around, and so he's also making the satellite contact. Okay, either space communication through a satellite. So now, so we can always do in two ways the space communication. One way, that is a one-way communication, is just receiving the signals from the satellites, and two ways you can also transmit. So one can transmit. So two-way communication is possible only when you have a valid license. Okay, when I say license, of course, I mean it's an amateur radio license. If you become a radio ham, amateur radio operator, so one will be authorized and will be having a valid call sign and a license to transmit a signal, a class of a particular license, authorizing them to even transmit. Okay, though in that case, you can possess wireless equipments in your home, and using that, you can also talk through the satellite. You can send the data through the satellite and receive it. But this, I'm telling, this is only for the amateur radio satellites, not any other satellite. It is, but the technology, as I said, the science, the technology, everything remains the same. But we will be doing in a much simpler way. Okay, so to begin with, one-way communication is very easy, very simple, and very inexpensive. You don't need any license at all for this. Okay, I'll just tell you how you can do. And so what we can receive from these satellites. So I already told there are a class of satellites called amateur radio satellites. So we can receive data, images, and telemetry and beacon signals from various amateur radio satellites, and of course from space stations. Okay, now right now we have International Space Station, and we have so many student-made satellite. So starting from tomorrow, 5:30 IST Indian Standard Time, there will be beautiful images, greeting cards will be sent by the Russian cosmonauts on board the International Space Station for 2 days. So these are all the interesting activities. Okay, they are going to send a beautiful greeting cards, radio greeting cards from International Space Station by this Russian cosmonauts for about 2 days. So we can try to receive all this. So to receive, it needs a simple setup. Okay, and apart from that, we can also receive live weather images from American and Russian satellites like NOVA and Meteor. It's a Earth observation satellite. Beautiful real-time weather images, and you can get a lot of. And already I told you. So tomorrow the greeting cards will be sent on a mode called slow scan television, SSTV, from International Space Station for about 2 days, for about December 1st and 2nd. And sometimes we know we'll be lucky to get an opportunity to talk to the astronauts on board the International Space Station, because most of them are hams. For example, the latest Crew 1 on SpaceX, all the 4 astronauts, the one Japanese and the 3 Americans, are all having amateur radio license. And when they get the opportunity and the time, they'll be talking to the hams on the ground, on the Earth. So these are all the signals and opportunities we get when we can have a receive. That means, you can just receive them. But if you want to transmit and if you want to talk to the astronauts, you need to have an amateur radio license. And now let us see what all the things we need. So we need a simple, sorry. So what we need is, we need to know a little knowledge, a basic knowledge about the tracking. Okay, by installing the software, if somebody is interested, you can just call me anytime. I'll give my contact address in the end of my presentation, and I'll help you out. So you can just, all that you need to know when a particular satellite is going to come. And so that is called the past timings. By running the software, you will come to know. Second thing is, if you want to receive some signals from space, obviously one should have an antenna, a simple antenna. You can see in the here in this image, it's a simple antenna. And third one is a receiver. So, and okay, so you can make a simple handheld antennas like this. And maybe in the later stage, if you are learning a little bit of electronics and communication, you can start making little better antennas like this. All these antennas are meant for receiving satellite signals. You just know, thereby you are going to learn about the antenna theory, electronics, wireless communication. And of course, this is another recent advent. It's called the software defined radio. This all available on online, starting about 2.5 to 3,000 rupees. From there you can get, and these are all the simple receivers. You just all that you what it needs is you have to plug into your computer USB port and run a different software for this, and this small piece like your flash drive USB stick, it is a receiver. So it is a small piece of a hardware totally defined by a software, so you can receive the signals from there. Okay, so now, so these are the ones which I was telling you, like so this is a NOAA American satellite. It's the Earth observation satellite. As it flies over our places, it will be scanning the place below that Earth, and it will be transmitting the real-time live images, weather images, so we can receive it. And so all that what is required is, so a satellite tracker program, a simple antenna, a FM receiver or a SDR, that is a software defined radio, and audio cable. And so you need to run a couple of softwares, and most of the softwares are free. Okay, so you can have a weather station in your home. Just imagine, as a hobbyist, if you can have a weather station at your home, so it's so nice, and thereby you are going to learn so many things. Now, this is the one major area of a space agency. See, one is, see, this is how it's going to look like. One is, you have a space segment which is already there. We don't have to spend any money. Somebody has spent their money and they are flying their own satellites. And now we are going to receive some signals from certain class of satellites. And again, I'm reiterating, not from all the satellites, from a certain class of satellites. And the signals are going to come from these satellites from space. And it's going to be received using a simple antenna on our terrace. And then we have a simple radio, either a FM radio or a software defined radio, and you already have a computer and interface that, and you are going to have beautiful images displayed on your computer screens. And this is the one area where you can learn many things. One is about the, see, this is just a small entry point into the big world of space communication. So this is how our setups at home looks like. A simple weather satellite receive station. If some of you are interested to play with the satellite and with the space communication, you can just give a modest beginning. Okay. And see, these are all some of the images which I keep receiving. Okay. Using a very, very simple receive setup. And you can see this is the this is the Arabian Sea and the Gulf region. And two-way, I already told you, two-way communication is, if you want to transmit and receive, it is called a two-way communication. But to have, if you want to transmit some to signals to satellites, certainly one should be licensed, a appropriate license. In this case, easiest way is you can become a radio ham, okay, a amateur radio operator, get a valid license, and you will be allowed, authorized to uplink, to send the signals to the satellite if you have an appropriate class of amateur radio license. So now you can establish two-way communication instead of one-way. You can use the transponders on amateur radio satellites, and you can exchange the data, SSTV images, and your packet signals. You can exchange your voice with astronauts if you get an opportunity, and if you can talk to many friends around the world on the far off side distances using amateur radio satellites. So you are going to learn a lot, many things, just by giving a very modest, simple beginning as a hobbyist. So these are all the ham radio missions. So many missions are flown. In fact, I just told you, even the SpaceX Crew 1, all the 4 astronauts, radio amateurs. Definitely, we are all hoping that if they get the time, free time, they'll be coming on air, coming, talking to the amateurs on the Earth. And definitely from tomorrow, you can, if you have known some ham radio operators, you can just go to their house. You can listen to the frequencies tomorrow, starting from 5:30 Indian Standard Time. Whenever the International Space Station comes over India, we can listen to the signals being transmitted by the Russian cosmonauts in a mode called slow scan television, and they'll be sending beautiful greeting cards. Okay, so these are all the ham astronaut photographs. And two-way options, I just told you all that the fourth component here is the transmitter. Otherwise, all the first three remain the same. So these are all some of the additional equipments and accessories. And I don't want to go deep into that. Just I want to conclude by telling that space communication or space science, and maybe in particular the satellite communication, could be pursued as simple as this. That means you don't need much uh, expenses, you don't to spend money, or in a very very simple way you can establish. But literally we'll be going to learn many things about the space, say space science, space communication, electronics, wireless communication, and everything. Okay, so really, I don't have time to give the demo of the Orbitron tracking satellites and all that. And certainly, if Chigru can provide another opportunity, we can have advanced, what you call, sessions specifically on this subject. So, of course, I have a live demo of software-defined radio, which may not be able to do it today. Already, I just end of my time. So these are all the live demo. In fact, wanted to give. So I want to really complete at this point. The bottom line of my talk, or of course, the hobby of satellite tracking is it's a fun and challenge packed with science. And this is an underground facet of observational astronomy. If you just become into this, certainly you will be motivated to take up astronomy as well. And this hobby is sure to induce a scientific interest among students, and sure to provide an insight into orbital mechanics, rocket propulsion, space physics, satellite applications, mathematics, computer programming, amateur radio, astrophotography, and many more. Just by the listening or learning the tracking of satellites, one can end up learning anything, all this what I have said just now. So as a hobbyist, I'm sure one can develop different levels of scientific and technical knowledge, from the lowest level to the most advanced level, having some research application goals in mind. So be a part of reality. I always tell, become a radio ham if you want to be a part of the reality. So try to become an amateur radio operator. Certainly, you will become a part of the reality. So thank you very much. I hope this presentation would have provided some basic ideas and information regarding real-time tracking and satellites and space communication. Thank you very much, and I thank you, Chigru, the Center for Excellence, and it's a new startup, and I think they are going to come in a very big way. I wish, and my good wishes and greetings to Chigru for all the best in their future endeavors. So thank you very much, Surendran. Thank you very much, Bharat, and Anupama, for giving me a chance, an opportunity to meet all of you through this video mode of my presentation, the space communication, the real-time tracking of spacecraft and space communication. And so this is my contact details. If any of you are interested, you can always make a note of it and just give me a call to this number and to my mail ID. And certainly I'll be in a position to help you out during my free time. So thank you very much. Thanks everyone. And once again, thanks for giving a very patient listening. So bye for now. I'll be on air for some time. It's over to you, Surendran. If you have any doubts, questions, please go ahead.
Thank you, sir. Thank you very much. And it is once again a wonderful session from Subramani, sir. Also, one student, I guess, has commented in YouTube. Hello, Subramani, sir. I always remember you when I go out to watch the visual sighting of satellites and mainly ISS. Madhvesh Bharatwaj has commented. Yeah, it is nice to hear from a student, maybe who attended your talk sometime, some days ago or something. So I guess.
Yeah. Hi, Madhvesh. Thank you. You are one of my favorite students. Okay. Thank you. Thanks for watching that. Any other questions about Surendran?
Yeah,
and your
we are looking
feedback,
for
how was it, Surendran?
Yeah, it is fine, sir. Somewhere we missed the connectivity. we face the connectivity issue, but it's fine. Once again, you have given a wonderful eye-opening session. Yeah, many students are also going to ask, I guess. Students, it is time for you. You can ask your questions. If you have any comments or questions, you can share here. We are looking forward to speak. Sir Subramani sir, in comments, public chat, participants are posting few questions and comments, I guess.
Yeah.
Okay, Amirtava version, PPT, maybe we will share few screenshots which will be useful to you. The PPT belongs to organization Radio Club. So we will give the links, whatever important links we will share with you. We will share the share notes to your registered mail ID. Hope you have registered. Otherwise, just fill that attendance form. It will help us to share the meeting links and important notes, a few tracking links, Orbitron links. We will share with you. Devankrati has commented. Devankrati, you have asked. Madhyalagan, kindly mute. Yeah, thank you, Madhyalagan. So Devankrati, you can use various sky watching tools. Subramani sir, sorry, it is related to astronomy. Maybe I will address this question. I will hand over to you.
No, please go ahead.
Yeah, Devankrati, you can use a tool called Stellarium. Stellarium is one kind of software you can use to watch night sky observations for stargazing. You can use that tool, Stellarium. You can download it from stellarium.org. Anyway, we will send that mail to you. We will send that link to you. And Madhyalagan, you have any questions? You can ask Madhyalagan.
நான் இங்கிலீஷ்ல கேட்க வராதுண்ணா, அதனால தமிழ்லயே கேட்டுடலாம் பாக்குறேண்ணா.
தமிழ்ல கேளுங்க.
இல்லண்ணா, இந்த சேட்டலைட் ட்ராக்கிங் சாஃப்ட்வேர் கொடுத்தாங்களாண்ணா. ஹலோண்ணா,
நீங்க மதியழகன் கேட்டுருங்க, கேட்டு முடிச்சிருங்க, அப்புறம் பேசிடலாம்.
இல்ல சேட்டலைட் ட்ராக்கிங் ஆப்ஸ் சாஃப்ட்வேர்லாம் கொடுத்தாங்களா, அந்த ஆப்ஸ் எல்லாம் எல்லா ஆப்ஸுமே டெவலப் பண்ணணுமா, இல்ல எல்லா சாஃப்ட்வேரும் டெவலப் பண்ணணுமா, இல்ல எனி ஒரு சாஃப்ட்வேர் டெவலப் பண்ணா போதுமா? கொஞ்சம் கேட்டு சொல்றீங்களாண்ணா? இல்ல எந்தெந்த மாதிரி சேட்டலைட்டை ட்ராக் பண்ணி அதுல என்ன யூஸ் பண்ணிக்கலாம் நம்ம கொஞ்சம் எக்ஸ்பிளைன் பண்ண.
Subramani sir, just a minute, sir. I will translate this question and then maybe you can answer.
எனக்கு புரிஞ்சுது.
To other participants, maybe you can give the glimpse of this question to other participants so that others also can understand the question and answer, I guess.
இப்போ நான் என்ன தமிழ்ல ஆன்சர் பண்ணுமா இங்கிலீஷ்லங்களா?
சார் நீங்க தமிழ்ல அட்ரஸ் பண்ணிடுங்க சார், நோ ப்ராப்ளம். டு கிவ் அ ஹோல் பிக்சர் டு தி அதர் பார்ட்டிசிபென்ட்ஸ், அவங்களுக்காக நம்ம இங்கிலீஷ்ல எக்ஸ்பிளைன் பண்ணலாம்.
Okay, so now there's a question from Madhyalagan. He wants to know whether the apps are there or the softwares are there for this, and whether we have to download all the softwares, and what are the uses of this. That is what is question. Okay, and just to my answer is, there are many apps also for Android. Of course, you can download that. And second thing, there are many softwares online for the PCs also. You can download, but not everything. You can just have one or two. See, everything is going to do the same function, but in a different ways. Okay, but there are something which are very simple and some of them are complicated. That is the reason I just told you, you try with Orbitron, the first one which I showed you. Orbitron is a very simple and a straightforward software, particularly for the beginners. Okay, and the users already I told you. See, just by learning that, we are going to learn something about the space science, because space science is a huge subject, but we are just giving a very simple, a modest entry into this. Okay, a first step towards that direction. when you can learn something about the tracking, you are going to learn many things associated with the launch of satellites, why we are launching in different altitude, different inclinations, all that. Okay. And slowly, if you are really interested, you can make yourself as a space scientist. That is what I'm telling. Any other spaces is and become a space scientist. You can make yourself a self-made space scientist. Okay. Definitely, there's not going to be any difference if you really learn and understand to that extent what some of the people have learned. Okay. In no way it's going to make a difference. And here, you're going to learn electronics. You're going to get an opportunity to learn electronics, and particularly in the area of wireless communication. So you will be knowing, it's all depends upon the interest, your interest in this. Okay. And definitely there is no monetary benefit, but later on, if you can acquire some knowledge and that you can apply it as a own startup, you can do that. Okay. This is what the usage now. A huge science, a huge technology, we are going to just teach you in a simpler way, and we cannot really make you a big expert taking all the way. We can just show you some, put you on the track. This is what we are trying to do. Okay. Madhyaragan, மதியழகன மதி எஸ் இப்போ நான் தமிழில் சொல்கிறேன். இதை வந்து ஆப்ஸ் இருக்கு, ஆண்ட்ராய்டுக்கான வேண்டிய ஆப்ஸும் டெவலப் பண்ணியிருக்காங்க. ரெண்டாவது பிசிக்கான வேண்டிய சாஃப்ட்வேர்ஸும் இருக்கு. அதில் நான் அந்த ஸ்லைடில் காமிச்ச அத்தனையும் டவுன்லோட் பண்ணணும்னு அவசியம் இல்லை. அந்த ஆர்பிட்ரான் ஒன்று நீங்கள் இப்போதைக்கு நீங்கள் அதை டவுன்லோட் பண்ணி அதில் நிறையாவே தெரிஞ்சுக்கலாம். ஓகே. ஒவ்வொன்றா தெரிஞ்சுக்கிட்டு இதில் வந்து நல்ல ஒரு பெரிய எக்ஸ்பர்ட், ஒரு மாஸ்டர் ஆகலாம் நீங்கள். ஓகே. இதுக்கு என்ன வேண்டி இருக்குன்னு முக்கியமானது உங்களுக்கு ஒரு என்னது இன்ட்ரெஸ்ட் இருக்கணும். ரெண்டாவது இன்வால்வ்மெண்ட். யூ ஷுட் இன்வால்வ் இன் திஸ். இதுல உபயோகம் என்னன்னா, இதுல இருந்து என்ன பிரயோஜனம் என்னன்னா, நீங்களும் உங்களை ஒரு 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 ஸ்பேஸ் சயின்டிஸ்டா உருவாக்கிக்கலாம் சொந்தமா. ஓகே. மற்றவங்க இந்த ஒரு இஸ்ரோலயே வேற எங்கேயோ ஒரு இடத்துல ஒரு ஸ்பேஸ் சயின்டிஸ்டா ஒருத்தர் இருக்காங்கன்னா, அவங்களுக்கும் நமக்கு என்ன வித்தியாசமா இருக்குன்னு ஒரு காலகட்டத்துல அவங்க வந்து ஒரு கம்பெனி, ஒரு ஸ்பேஸ் ஏஜென்சிக்கு ஒர்க் பண்றாங்க, நீங்க தனியா இருக்கீங்க, அவ்வளவுதான். ஆனா அவங்க என்ன தெரிஞ்சிருக்காங்களோ அதே அளவுக்கு நீங்களும் தெரிஞ்சுக்கலாம். எப்படின்னா நீங்க சொந்த முயற்சியால தெரிஞ்சுக்க போறீங்க, அவ்வளவுதான். ஸோ இதுக்கு வந்து ஒரு வழி இருக்கு, சொந்தமா தெரிஞ்சு கத்துக்கிறதுக்கு ஒரு வழி இருக்குன்னு தான் நாங்க இந்த ஒரு டாக் மூலியமா உங்களுக்கு தெரியப்படுத்தியிருக்கோம். ஸோ இதை வந்து இப்ப என்னன்னா, ஒரு பெரிய பெரிய இஸ்ரோல, பெரிய நாசா அந்த மாதிரி எல்லாம் அவங்க பெரிய ஸ்டேஷன்ஸ் எல்லாம் வச்சு என்ன பண்ணிட்டு இருக்காங்களோ, நீங்க வீட்டுல வந்து சின்ன விதத்துல நீங்க இதை செய்யலாம். ஆனா அந்த சயின்ஸ் வந்து அதே தான். ஃபார் எக்ஸாம்பிள், ஒரு நியூட்டன்ஸ் லா எடுத்தீங்கன்னா, அது வந்து யாருக்கா இருந்தாலும் உங்க டீச்சருக்கும் அதே லா தான், சொல்லி கொடுக்குற பையனுக்கும் அதே தான். அந்த மாதிரி இது வந்து இந்த சயின்ஸ் வந்து இட்ஸ் கோயிங் டு ரிமைன் த சேம். அந்த சப்ஜெக்ட் நாலேஜ் எல்லாமே ஆனா நீங்க வந்து இது சொந்தமா கத்துக்கிறீங்க. ஓகே. இதுதான் வித்தியாசம் மதியழகன். ஓகே. புரிஞ்சுதுன்னு நினைக்கிறேன்.
தேங்க்யூ சார். வெரி தேங்க்யூ சார்.
Thank you.
Sir, I have question. Is it okay to I ask in voice?
They just fine. In which language you are comfortable? English,
In
Tamil,
Hindi.
Hindi. Sir, is it okay to speak in Hindi, or we have a translator here? Maybe
Tejas,
he will translate. Yeah, Tejas.
Tejas, good morning. Not so good in Hindi, please. Sorry.
Fine. No problem, sir. Subramani sir, we have a translator here. One of my friends is here. He will translate the question. Tejas, you can ask your question.
अच्छा ठीक है. मेरे सवाल है कि अभी आपने बताया कि रेडियो साइंटिस्ट बन सकते हैं, तो घर पे इस तरह से रेडियो सैटेलाइट भी बना सकते हैं क्या? दूसरा सवाल है कि जो लोग समझो इस फील्ड के अंदर आना चाहते हैं, लेकिन जिनकी पढ़ाई पूरी नहीं हुई, मतलब 10 तक हुई है या 12 तक हुई है, इस तरह से लोग भी बन सकते हैं क्या साइंटिस्ट, अंडर ग्रेजुएट?
வெயிட் மினிட். வணக்கம் சார். சார் அவர் என்ன கேட்குறாருன்னா, ஒன்று ஹலோ ஹலோ ஸோ தேஜஸ் இஸ் ஆஸ்கிங் தட் to make a satellite communication at home, is it possible to make at home? One. Second question was that how to how to become a how to come into this field if or get graduated if you only have 10th or 12th of qualification. Is that possible? So those were the two questions he asked.
Who answer now? Who needs to
Sir,
answer?
sir, you can answer, sir. He's asking about how to setting up tracking satellite communication in his home, and he's asking about how we can become a space communication.
Yeah, that's right.
In
No, I need to answer in English.
you can answer in English, sir. We will translate. Tejas, is it fine? You can understand English or only speaking problem?
I'm fine in English. You can speak.
Okay.
Yeah.
Okay, Tejas. See, first thing is tracking from home. Yeah, I've told in the beginning itself, you can do all this from your home. You are going to do from your home. Tomorrow you can do. All that I told you, what you need is one computer, install the software, and learn the basics. And I just told you what all the things you need. And if you have a computer, you can track the satellite from your home, from your computer. Okay. Now, once if you're doing the tracking, you know a particular satellite is going to come at some particular time. How you're going to make sure it is really you're doing in the right way? How do you know? You cannot see the satellite. You cannot hear the sound from the satellite like an aircraft. But there are two ways. One is you can see the satellite or you should hear some signals. Okay. Some of the satellites are visible to the naked eye. Okay. Only during certain time, not all the time. So using this tracking, if you have learned something about real-time tracking, and if you know from the satellite, a particular satellite which is going to come at certain time, if it's a huge one like International Space Station, you can use your eyes to see the satellite from the sky. But it is not all the time, not every day. Okay. But there are certain satellites which come, there are satellites, a certain class of satellites, when it comes, it transmits signals. If you want to receive the signal, you need to have a receiver, isn't it? So that also you can have. I just clearly told you. Just you should have one simple antenna. You should have one receiver, either a FM receiver or a software-defined radio, and connect that to your laptop or a PC. Run a software for that, and you are going to receive the signal from the satellite. So when these two matches, for example, when the satellite comes at the right direction, right time, and if the predictions you have already made using a software, you are on the job. You have learned the real-time tracking of satellites using softwares, and you are receiving the signals. And once if you receive the signal, you can decode it also as a second step. So in this chain, you are going to learn so many things. One is the tracking of the satellites, and
sir,
all that you're going to learn, right?
Sir, 1 minute. Sir,
Yes.
1 minute. My question is not that. My question is, it is possible to be made in home radio telescope to make in home. Is possible?
No, you are now mixing up two things. Are you talking about radio telescope or
नहीं
what is
माय
it?
क्वेश्चन एक मिनट मेरा सवाल वही था, रेडियो टेलीस्कोप बना सकते हैं क्या घर में? वही मेरा सवाल था। सैटेलाइट टेक करने के लिए नहीं, सैटेलाइट टेक करने के लिए तो कंप्यूटर से इस तरह से हो सकता है, लेकिन रेडियो टेलीस्कोप बना सकते हैं क्या घर पे सामान्य बेसिक ज्ञान के द्वारा, सामान्य तौर पर?
Okay.
Okay,
Subramani sir, maybe I will answer.
Surendra will answer because radio telescope and satellite doesn't go.
Yeah. Tejas, yes, you can make your radio telescope in your home. It is very easy setup. You just need the antenna kind of arrangement, and you also know about the signal which emitted by the various celestial object. Mostly radio waves we will get from sun or other stars, galaxies, or whatever. But those radio signals are very, very large. We can't be able to predict get that signal with very simple kind of this antenna setup. We need huge radio dishes to collect those signals, because those signals are very large. you can just compare those signals. It is larger than one huge house, okay, huge apartments. So those kind of signals can't able to predict with small kind of dish antenna setup. That is why radio telescopes are built by built in about the radio telescope in Pune and some other radio telescopes in various desert like areas, sea and some areas. So yes, you can build your radio telescope. You can also watch take photographs of various astronomical objects in radio waves. But once again, it is much costlier. At the same time, it is not that much easy to get signal from very deep objects like galaxy clusters. Yes. But answer is yes, you can build, but very small antenna to get signal from sun or some nearer celestial objects. That's all. Thank you, sir. Subramani, sir. Yeah.
Yeah, okay. Any other questions?
No?
Yes.
சேட்டலைட் கம்யூனிகேஷன் சேட்டலைட்ல இருக்கிறவங்க அங்க இருந்து கம்யூனிகேட் நம்ம பண்ண முடியுமாண்ணா? கொஞ்சம் எக்ஸ்பிளைன் பண்ணுங்கண்ணா.
சேட்டலைட்ல ஜெனரலா யாரும் இருக்க மாட்டாங்க. இன்டர்நேஷனல் ஸ்பேஸ் ஸ்டேஷன்
ஸ்பேஸ்
ஸ்டேஷன்ல ஆள் இருக்காங்க. இப்போ 7 பேர் இருக்காங்க. ஓகே, இதுல எல்லார்கிட்டயும் எல்லாம் பேச முடியாது. அதுல ஹாம் ரேடியோ லைசன்ஸ் அமெச்சர் ரேடியோ ஆபரேட்டரா இருந்து அவங்க அந்த டைம் இருந்து அவங்க அதுல பேசும்போது நம்ம பேசலாம். ஓகே, அதுக்கு நம்ம கிட்டயும் லைசன்ஸ் இருக்கணும். ஹாம் ரேடியோ லைசன்ஸ் இருந்தானா பேசலாம். அண்ட் அதர்வைஸ் இன்டர்நேஷனல் ஸ்பேஸ் ஸ்டேஷன்ல இருந்து சில நேரம் சிக்னல்ஸ் வரும் தானா. அந்த சிக்னல்ஸ் வேணும்னா ரிசீவ் பண்ணிக்கலாம். ஓகே, நம்ம பேசணும்னா முதல் நம்ம கிட்ட லைசன்ஸ் இருக்கணும். அண்ட் அவங்களுக்கு நேரம் கிடைச்சும் போதுதான் அவங்க பேசுவாங்க. அவங்களும் ஹாம் ரேடியோ ஆபரேட்டரா இருக்கணும். இப்போ நான் சொன்ன கிளியரா இந்த க்ரூ 1 இப்போ ஸ்பேஸ் எக்ஸ் இப்போ ஒரு 10 நாள் முன்னாடி அவங்க போனதுல 4 பேர் போயிருக்காங்க. அந்த 4 பேருக்கும் அமெச்சர் ரேடியோ லைசன்ஸ் இருக்கு, கால் சைன்ஸ் இருக்கு. அவங்களுக்கு டைம் கிடைச்சு அவங்க முடிஞ்சதுன்னா அவங்க பேசலாம் அங்க இருந்து. அப்ப பூமியில இருக்க அமெச்சர் ரேடியோ லைசன்ஸ் ஆபரேட்டர்ஸ் லைசன்ஸ் இருக்கவங்க அவங்க கிட்ட பேசலாம். புரிஞ்சுதா?
ஓகே சார். ஓகே சார். தேங்க்யூ சார்.
ஓகே. மதியழகன் எந்த ஊரு?
Madiyalan from
திருச்சி. திருச்சி சார்.
ஓ, திருச்சி. வெரி குட். ஓகே, ஃபைன்.
Okay, Madiyalan's question is whether we can communicate with all the astronauts, those who are boarded in ISS. Yes, the question is no. Only we can speak with the astronauts, those who are having a valid amateur radio license. As well as when we are going to speak, we also need to have a amateur radio license. That was the answer. And yeah.
And also when they get free time, only then they will talk.
No, how to get the amateur radio license? So
Yeah,
tell about the
exactly
amateur radio license.
Okay, Madhyalagan, it is very simple process. Once you are in 14 age, I think 12, sir, 14, 12, which age, sir? Which age group is?
Okay, 12 also. When you are 12 also, you can get.
Yeah. 12, you can write the exam at WPC. It is very simple process, Madhyalagan. Maybe Subramani sir is the right person to explain about it because he's a pioneer in that domain, ham domain. Yeah.
Can I go ahead?
Yes, sir.
Okay, Madhyalagan, if you can understand English, I'll tell in English. And I think it will be helpful to others also. Is it okay, Madhyalagan?
Okay, thank you.
No, shall I tell you in English?
Fine, sir. You may speak in English, sir.
Okay, Madhyalagan, amateur radio or ham radio is a hobby. Okay, hobby pursued by individuals who are interested in learning electronics, particularly in the area of wireless communication. This is a hobby, but Vichitramana hobby. It's a very unique hobby where one needs a license. Okay, so license to transmit. The license is issued by Government of India, Ministry of Communication, and for that, if you want to get a license, you have to take a simple test. If I tell examiner, you will get scared. So it is a simple test. Like when you go for a driving license, you need to take a small test, then they'll give you the license to drive the vehicles. Likewise, if you want to use the wireless equipments, you need to have a license. And now this hobby is talking to others or making contact with other parts of the globe using wireless transmission. See, when I say wireless transmission, you need to have wireless transmitters. So this you can have in your home, provided you should be licensed. When you have a appropriate valid license from Government of India, you can possess, maintain, and work an amateur radio station. You can have a small amateur radio station in your home, and you can operate that wireless equipment from your home. Okay, for this license is required. And here, when you take that test exam, a simple exam or a test conducted by Ministry of Communication, all that you need to know is basic and fundamentals of electronics. Anyone above the age of 12 years, they can take up the exam, and they all that what they have to know is basics and fundamentals of electronics. And second thing is the radio rules and regulation. Like when you take a driving license, there is certain rules what you have to do, what you should not do. Likewise, there are certain rules binding this amateur radio operation. So you should know that rules and regulation and the basics of electron. If you know these two things, you can take up the exam. And third one is Morse code. Morse code is optional, it is not compulsory. If you know, you get a better license. Okay, a better class of license. So this is what ham radio. See, ultimately everybody will ask the question, what you are going to get, what I will get if I become a radio ham. Nothing you will get except knowledge. Okay, so if somebody wants to build a radio telescope, he's not going to make money out of it. It is going to enhance his knowledge. That is what anything you do in science. Secondly, you can think in a way of doing money, but the primary function is not for that. We are all here to impart education, knowledge. Okay, so this is a hobby where you cannot make money. You are going to learn knowledge. You are going to learn something, a big technology, science, as a hobbyist. So that is what. Madhyaragan, I think, I hope you got it right.
I guess Madhiran got. Otherwise, maybe I will explain, sir. I have his contact. I will explain him about the reason. And there are two questions in the chat box, sir. He asked. First question he asked: can the space signals be used for research purpose in the field of astrophysics? And another question is, sir, is it possible to make homemade antenna and receiver from stuffs available in house? First question, maybe I will answer, sir. Second question, I guess you may answer.
Yeah, please go ahead. Go ahead.
Yeah, first question, yes, yes, we can get the signals from signals for the research purpose in the field of astrophysics. There are so many data available in online. Also, you may request some institutions like some research institutions. You can get the data for your research purpose. You can officially write a letter from your institution or from your head of the institution, your professor. You can ask the data and you can analyze it for your research purpose. Yes, you can receive the signal. And but for homemade setup, like observatory setup, you need some specialization. Yes, you can also build your observatory kind of arrangement to get receive signals in the optical waves or radio waves for your research purpose. Yeah. From Chiguru, we are going to help all this kind of homemade setup and observatory building, ground station building, and all. We are going to help students, many students, those who are interested in the field, in the domain. Yeah, we are going to help you. Second question, Subramani sir, you can answer. Thank you.
Yeah, this is the second one is homemade equipments. Anything?
Is it possible to make homemade antenna and receiver from stuffs available in home?
Yeah,
Basically
very
about homebrew.
Yeah, very much, very much. See, when we do things at home, we generally in ham world we call as a homebrew. Okay, we can do. See, now as one of the prerequisite for the exam is the basic electronics. Knowledge of basic electronics is required. See, when we possess that basic knowledge of electronics, it is not at all difficult to make our own system. See, right from antenna, a simple antenna, you can end up making your own satellite, because amateur radio is all about learning. Okay, it's all about learning science, technology as a hobby. So when you have a fundamentals, when you know basics and fundamentals, always you can build yourself over that. Okay, so you can keep reading a lot of electronics, and finally you can end up becoming an expert in that area. So you can become a communication expert, you can become a communication genius, you can become a space scientist, you can make your own satellite for that. Nobody is going to stop you. Okay, so you can make everything, provided you should have interest, involvement, and determination. If anyone having this, we can achieve in any field. Hope you got it right.
Yeah, thank you, sir. This is typing. So once again, thank you, sir. Thank you very much. I think there is no more questions in the chat box. YouTube info.
Yes.
Yes.
Sorry. From Sir Subramaniam. ISRO.
Yeah.
I have one question. I have one question. If okay to contact you on Telegram, it's okay to contact. I have some questioning idea for ISRO and this country.
No, what is that? What is your name? Could you please tell me, repeat your question, please?
I have some question and idea for ISRO and for India and ISRO. Using using rocket to generate electricity.
Is there anything, Surendra? Can you get what it is?
Tejas, yeah, Tejas, your question is not clear. Background noise is there. Kindly speak a bit louder.
Guys, it's really true. सर मेरा अब आवाज आ रही है ना?
Yeah,
ना क्लियर?
now it's fine. Clear.
मेरा सवाल था कि इसरो से संबंधित मेरे कुछ सवाल आइडिया है, और एक मेरा आइडिया है कि रॉकेट इंजन से बिजली बनाई जा सकती है क्या? टेलीग्राम से मुझे संपर्क करना था आपसे, वहां पे बातचीत हो सकती है क्या?
Tejas, wait. Tejas, we don't have a translator here. Just a minute.
Yeah.
Tejas, speak now.
मेरा कुछ सवाल और आइडिया थे इसरो के संबंधित और अपने देश को आगे बढ़ाने के लिए। उनके लिए मुझे वो इसरो के अंदर जो काम करते हैं ना, BS सुब्रमण्यम सर, उनसे संपर्क हो सकता है क्या टेलीग्राम पे? और एक आइडिया मेरा ये था कि रॉकेट इंजन से क्या बिजली बनाई जा सकती है क्या? इसके ऊपर मुझे चर्चा करनी थी, उनसे गाइडेंस चाहिए थी बस।
Surendra?
Sir, yes, sir. Just a minute, sir.
What is this?
Yeah, so Tejas is asking. He's very much interested in into the development of the nation and into ISRO and stuff like that. So he was asking if is there any way to contact ISRO and Subramanian sir and so on. The second question was, is there any possibility to generate electricity from rocket engines? So those were the two questions he asked.
Okay, Tejas. The second question is no. It's rocket engines are not meant to generate electricity. Okay. So in fact, a different type of rocket engine needs electricity. Okay, so for that it is a totally a different thing. So it's not a wise, just converting, trying to get energy or electricity from a rocket engine. So we have simple generators and dynamos for that. Okay, alternators to get the electrical energy, and of course we have different ways of getting it. Like we have hydroelectric stations, we have thermal, and we have nuclear power stations and all that. So I hope you must be knowing about it. But we have different kinds of rocket engines, okay, using different technology, soil, solid fuels, liquid, and of course electric propulsion. Okay, so using electricity you can drive an engine. So that is totally a different one. And the first question is coming to ISRO and meeting me or something like that. Right now, no visitors allowed. And of course, I am not very clear about your question. If you like, if your question was like joining ISRO, yes, you can always join ISRO in your different capacity. Here, two ways. One is the technical and non-technical. And if you want to join technical, right from technicians up to the engineers, you can join ISRO, having minimum qualification like Industrial Training Institute up to PhD or much above that. Okay, there are different grades of vacancies available. So that is about that. And as a visitor, if your question was like dropping in visiting ISRO, right now due to the COVID, so visitors are not allowed. Maybe once if this is over, maybe we can arrange for it. Over.
And sir, no, I'm not visiting. I'm contacting. I need guidance for rocket. I'm saying to, it's possible to generate electricity from rocket engine. We
No,
can
that
use.
is what I'm telling.
Sorry,
Generating electricity from rocket engine is not a viable thing.
now it's not possible. Now you think not is possible, but I think it's possible. That's why I need guidance. That's why I need to contact to discuss this matter in
No, no.
detail.
Why you need to develop electricity from a rocket engine? Rocket engine just stays in the space only for about 18 minutes or 20 minutes.
Sir, I know, different kind of rocket engine used. Solid kind, liquid type. I thought liquid type, liquid hydrogen and liquid oxygen to fuel to use rocket engine, right? Then we can make to generate electricity that from heat. That heat produce rocket engine, then from generate electricity.
Yeah, you can use it. You can, if that is the case. See, it produces energy in a different form. That energy you can always convert and get it.
Ah, that's why I need guidance from you and ISRO. That's why I need
No.
contact. I need contact.
You have to write to ISRO for that. Okay, you have to write to ISRO headquarters. You can get the address from the contact address from the website, ISRO website. You can always write to them, to my headquarters.
Okay, sir.
Okay,
We
thank you.
will,
Welcome.
Fine.
Hello. Hello.
Yes.
Hello, sir.
Doctor.
Sir.
Yes,
Dr.
Doctor.
Yogendra Kothari. Dr. Yogendra Kothari is speaking, sir.
Yes, sir.
Yes, please, sir.
Sir, what is the role of hydrogen in rocket propellant?
So this we use the liquid hydrogen and liquid oxygen for the cryogenic engines.
No, sir. Hydrogen, NH2, NH2. Hydrogen.
Yeah, we use only in the cryogenic engine. Otherwise,
yes,
we
sir.
don't use that in anywhere.
Okay.
And that is actually fuel as a fuel and oxygen as an oxidizer we use.
Okay. Thank you, sir.
Thank you, sir.
Thank you.
Yeah. Thank you very much, sir. I think it is going out of the context of this lecture, space communication technology. Yeah, questions are welcome, no problem. You can ask the question to your to our mail ID. We have given in the slide CSTERC@sigru.tech. We will address your question mostly. Yeah. If you have any questions related to space communication technology, we will address here. If you have any extra questions, maybe you can post to us. We will address your questions later.
Sure.
Because we are running out of time. It is already 11:50. If you have any questions, you can ask now. Otherwise, we will close the session. Okay, fine. So there are no more questions in chat box and here.
Sir, I have a question from you.
Yeah, yes, Tejas.
It's okay to I contact you on Telegram?
Yeah, you can contact in Telegram. That's fine. We have given the link. Yes, you can contact in Telegram. Okay. Yeah.
Thank you,
Okay.
sir.
Thank you very much, Subramani sir. Thank you very much. Really, it was lovely session. You have given a great eye-opening session, I guess. That is why so many questions and so many discussions. So once again, thank you very much, all the participants. Thank you for your patient listening. And so once again, we will introduce ourselves. CIGRU. It's a CIGRU Center for Science and Technology Education, Research and Communication. It is a cooperative structure, and we are intervening in science education, building satellites, ground stations, tracking, and educating you to get live tracking of satellites. Those kind of models we have. You can contact us in any time. Mail ID is here, phone number is here. You can contact us anytime. We will guide you, we will help you, and as well as we will support your institution. You can bring this information to your institutions or institution heads, that like doctors are here, professors are here. You can also contact us if you want to get a pioneer in that space technology domain. Subramani sir is available with us, and many scientists and technology persons, engineers are available here. We will help you to get good level of understanding and technology support in the space technology education domain. Yeah. So once again, thank you very much on all. Subramani sir, thank you very much for your wonderful session once again.
Thank you, Surendran. Thank you very much. Really nice. And thanks everyone for giving a very patient listening. And once again, I wish you and the CIGRU for all the very best in the coming days and coming years. And certainly, whatever we can help from our end, I'll also do it. And so, regards to everyone, the Bharat, Anupama, and other friends, your friends there, and everyone associated with this startup CIGRU. So, certainly, we will also be part of it whenever there is a requirement. So, have a nice day, Surendra, and everyone. Great weekend and festival greetings to everyone. So bye for now. So I'm also signing off. Bye bye, Surendra.
Thank you, sir. Thank you very much. Yeah.
I'll close down.
Yeah, fine, sir. You can close. Thank you.
Bye.